Hi students, this is Mr. Eckert, and we're going to go through target age 9, which says that you should be able to solve genetics problems involving complete dominance, incomplete dominance, codominance, and sex-linked traits. Now, as we go through the guided notes, basically we're going to go through how to do the Punnett squares for these, but of course this target mainly involves you solving problems using Punnett squares for these different types of inheritance patterns. So basically you need to do practice problems for each of these different kinds of inheritance. So first, remember when you complete a Punnett square for complete dominance, of course a Punnett square, again going back to basics, is just simply a box with 4 squares in it that's going to show the possible outcomes of a cross between 2 different individuals. So we're going to write the gametes for each parent on the top and left side of the square. So for example, you can see if we're going to cross a heterozygous flower, capital R, lowercase r, with a homozygous recessive flower, little r, then the gametes for the heterozygous individual, half the gametes would carry the dominant allele, the other half the recessive allele. And of course the recessive individual would only have recessive alleles to give. So then we fill the boxes by bringing the left gametes over and the gametes at the top down, and of course we would get this result. Remember, if you have a heterozygous individual, you always want to write the capital letter or capital allele first. Then we need to analyze the results, and that always involves figuring out the genotypic and phenotypic ratios or percentages. So of course in this example, half are going to be big R, little r, or heterozygous, half are going to be little r, or homozygous recessive. And again, you can write it out by the words as it shows here, or you can just write the letters, which is probably a little easier. But that's the genotypes and genotypic ratios. Phenotypically, half of these would be red if big R codes for red, half would be yellow if little r codes for yellow. Alright, for incomplete dominance, we're going to follow the same steps, only remember we use 2 different capital letters. So in this case, if we had, let's say, a red flower crossed with a white flower, the red flower, the gametes are going to be all big R, the white flower, the gametes are going to be all capital W. Then we're going to get 100% individuals with the genotypes big R, big W. So what do those look like? Going back, what do those look like? Those, of course, remember for incomplete dominance, they're all going to be pink, these individuals here. Because in incomplete dominance, they blend. For codominance, again, we're going to use 2 different capital letters. So again, if we cross a red flower with a white flower, or a red cow, I'm sorry, in this case with a white cow, then we would get all individuals that were capital R, capital W. And in cows, those would be called roan. Remember what those would look like. Those would be both red and white. They would have red hair and white hair both. Not a blend, as in incomplete dominance. Remember for sex-linked traits, and now it says X-linked. Remember we're going to use examples that are found only on the X chromosome. So we have to put the alleles physically on that X chromosome. So we're going to write them as exponents. Again, these can be dominant or recessive alleles. So we're going to use capital or lowercase letters. And again, men are designated XY and women are designated XX. So you can see here that the individual on the top is a woman who has normal vision, so the only alleles, gametes that she has to give are X chromosomes with a capital C. And if we have a colorblind man, here shown on the left, you can see he's got, of course, a lowercase c indicating color blindness on his X chromosome. And again, the Y chromosome has nothing on it. So when you fill out the Punnett squares, we have the result is 2 female offspring that are both carriers. Now they would both have normal vision because they both carry a dominant allele for color blindness, or normal vision, a dominant allele for normal vision, and 1 recessive allele color blindness. So this would be a normal vision female, but she's a carrier. And we have two males, both of which have normal vision because they're both carrying the dominant allele. So percentages for this result, again, we have 50% X big C, X little c, those are the females, 50% X big C, Y. What do those look like? 100% of those individuals have normal vision. You might want to say all the females are carriers, but that's how you do it. If you have any questions, please ask in class or sign up for a time to ask for help.